Okay, so last week you learned about a special factoring pattern called a difference of squares. Today you will learn about two new factoring patterns that will be the keys to one of the most important formulas that you will learn in mathematics. Now, before we do this, we're going to review a couple of ideas that you learned a long time ago. And we're also going to talk about how these relate to how we've been factoring recently. So, important terminology and formulas that you need to know moving forward through this lesson. A rectangle. So, a rectangle is a quadrilateral with four right angles, and the opposite sides of a rectangle are equal to each other. So, here's kind of what your diagram looks like. So, here's what a rectangle looks like. And you've probably seen these right angle markings before in the past. And then also, you've probably seen these markings to show that the sides are equal. If you haven't, you will learn about this in geometry. So if you look, typically we call the length of a rectangle L in the width W. Might also see, these two sides represented as B and H for base and height. Those are kind of interchangeable, doesn't really matter. Now, a square, on the other hand, is a special type of rectangle. Okay, and it's a rectangle that has four equal sides. So it has four right angles like a rectangle does. But here, all the sides are going to be exactly the same. So we typically call the side lengths of a square S. Now, what we've been doing is we've been using areas of rectangles to help us model either multiplying two polynomials together or factoring two polynomials. So using like the X box and the area model method. So a lot of the area models that we look at, even though we typically draw them as squares, really the rectangles that we've been looking at, the area models that we've been looking at are rectangles because the dimensions, the length and the width are different. So again, if we look at the rectangle to find the area, we would just multiply the length and the width together. And what we've been kind of what we've been doing recently is breaking up the length and the width into four regions and using that to help us factor. Now, the areas that we're going to look at today are going to be perfect squares. So the rectangles that we're going to use in our area model are going to be perfect squares. So what that means is that these dimensions, so this length, in order for the rectangle to be a square, the length and the width are going to have to be identical. Okay, so keep that in mind. So perfect square trinomial pattern. These are the new factoring patterns that you need to know. Now, if you can't memorize these, it's not the end of the world because these perfect square trinomials can be factored like all other trinomials using an area model or any other technique that you've learned. It's just that if you can recognize this pattern, it's going to help you factor a little bit more quickly, so be a little bit more efficient. And it's also going to help with the next couple sections that we're going to cover. So let's just prove real quick this pattern. So what the first pattern tells us is that a squared plus 2ab plus b squared equals the quantity a plus b all squared. So what we're going to do is we're going to use an area model to prove this. So what we're going to do is we're going to prove that a plus b all squared is equal to a squared plus 2ab plus b squared. All right, so let's do that. So if we look here, we're going to use an area model to do this. So a plus b all squared, remember, is just a plus b times a plus b. So what I'm going to do is I'm going to let this equal the length and this equal the width. But if you notice that length and width are identical, so this area model that we're using is actually going to be a square. Those are going to be the same. So a plus b, and then a and b, and then I'm going to break this up into regions like we've done before, and we're going to find the area of each region. So the top left-hand region, this first one, a times a is a squared. The second region is length A by length B. So that's AB is the area of that region. the bottom left-hand region is A by B in length, so that's going to be AB for the area of that region. And then the final region, the bottom right-hand region, is B times B, so that's B squared. So if we find the total area of this region, we're going to get A squared plus AB plus AB plus B squared. And if we simplify those terms, we get A squared plus, looks like we have two ABs, plus B squared. So it looks like, in fact, A plus B times A plus B equals A squared plus 2AB plus B squared. And then if we simplify this a little bit more, A plus B times A plus B can be rewritten as A plus B all squared, and that equals A squared plus 2AB plus B squared. So if we can recognize a trinomial that follows this format, and I'm going to show you this later, so you'll see this in future example problems, then we know immediately that it will factor, or when you factor it, it's going to look like this: A plus B, that quantity squared. Now there's a second perfect square trinomial pattern. It's A squared minus 2AB plus B squared, and that equals the quantity A minus B all squared. So we're going to prove this the same way we just proved the other one. So again, we're going to use the area model. And remember, this area model is a square because A squared, A minus B all squared is A minus B times A minus B. I'm running out of space. Let me do this down here. A minus B times A minus B. All right, so the dimensions are A minus B and A minus B. So again, we'll do our multiplication out. A times A is A squared. A times negative B is negative AB. A times negative B is negative AB again. And then negative B times negative B is positive B squared. So it looks like A minus B times A minus B equals A squared minus AB minus AB plus B squared. And I'm getting that from my area model up here. Now remember, A minus B times A minus B is A minus B, that quantity squared. And then if we simplify the right-hand side of this equation, we get A squared. Negative AB minus AB is negative 2AB plus B squared. All right, so it looks like those patterns are true. Those perfect square trinomial patterns are true. We just proved that they work. Now what we're going to do is we're going to see how these patterns can be helpful in our work. And that's what you're going to see in the next video. So you're going to see how to actually apply these factoring patterns. And then in the video that follows that, you're going to see how we can use perfect square trinomials to help us solve equations as well. Okay, so those videos will be coming up soon. I hope this one was helpful in explaining, where these formulas come from. Like I said, the next ones we will apply these formulas in factoring and solving equations. So we will see you in the next video.